Hello everyone. In this tutorial, I'll be solving problems from Physics past paper 2023 March series. So yes, let's go. So in this paper, let's say Physics paper 2 extended. So you should be a little careful in the beginning. Yeah, what G value you have to use. What G value you have to use. So it's defined, it's been told in the cover page, in the instruction part. So sometimes sentence will be reading instructions, sometimes they don't. So it's always not worthy to start reading with the instruction first, then dive into questions. Yeah. Okay. So first question, which list contains two scalar and two vector quantities here? So what is scalar, what's vector quantity? So scalar quantity, the quantity is having only magnitude on the number, right? For example, 2 kilogram, it doesn't have any direction, yeah? So just the number value basically, yeah? With the unit, along with the unit. So the value only. So this one going to be scalar. Vector is going to be value plus the direction. For example, you cannot say 3 kilogram up, yeah, or down. So 3 kilogram is going to be scalar. But when it comes for the force, for example, 5 Newton, where? To the right, up, down, or to a certain direction. So it's going to be magnitude plus direction. But here we have only magnitude on the scalar. So let's go. Which one has two scalar, two vector? So first one, distance is a scalar. Displacement is vector. So speed is a scalar. Velocity is what? The vector. Time is the scalar. It's going to be vector, sorry. Okay, here we go. It's a vector. Oh, 3 scalar, 1 vector. It's not an option. So B. Force is a vector. Velocity is a vector. Distance is a scalar. Mass is a scalar. Oh, this is the answer. Okay. So then if you want, you can go with C and D. So it's going to be wrong anyway. So yeah. Question number 2. Diagram shows the speed time graph. Be very careful. Speed and time. What the graph will show? What's acceleration? Yeah, but it has to let's say quantities, which is going to be speed and time variables, yeah. Which row describes the motion of the car at point X and Y? So we have to find that X first, then the Y. What's happening in X? Oh, speed is increasing. It used to be 2 here, maybe 5 here, maybe 10 here, yeah, maybe 10 here. Yeah, it's increasing along with the time. It is increasing, but what? Moving with a constant speed. It's not constant, of course. Moving with a constant, sorry. Moving with a changing speed, actually, yes. Moving with the, what? Changing speed. So either C or D, we eliminate A and B here. And what's happening in Y? It's not at rest. At rest means velocity is 0, okay? So velocity equal to 0 means at rest. So it's moving with constant speed. So speed is 10, let's say. And it's going to 10 for till this point, yeah? Whatever that it's given the, and stop there. So it's going to be constant speed. So the correct answer is D here. Next question. 4 objects are moving in a straight line. The table shows the distance moved by each object in each second of its motion. So which object is moving with a constant non-zero acceleration? Constant and non-zero. So they would say just constant. There are 2 options for the constant acceleration, yeah? Sorry. Moving with a constant acceleration. So constant acceleration, which is going to be so okay, let's go with the example here. So we will see constant and non-zero acceleration here. So distance moved in first, second, third, and fourth seconds. So this means 5 meters in the first second, in 1 second, in the first one. It moved 5 more minutes in the second. It means 5 more minutes in the second, like whole 1 minute. So basically, these are the speeds or velocities, this one. So let me erase. So these are the velocities, meter per second. Meter per second, you can say no problem. So see, it is used to be 5, again 5, again 5, again 5. There's no change in speed here. A is not an option. Second, 5 in a second. 6 meter per second, 7, 8. So from 5 meter per second, it changed to 6 meter per second. So it's like change is going to 1 meter per second basically. Then again 1 meter per second, again 1 meter per second. That's what I mean actually. It's going with non-zero change and it's going to be constant change. Yeah, 1 1 1 on each time. So correct answer is B actually. C is going to be, for example, 2 here, 3 here, 4 here. It is also it's also, what is that, acceleration, but it's what? Not constant acceleration. It's non-zero, but not constant acceleration. Even D, yeah? C and D is wrong here. So correct answer for 3 is going to be B. All right, question number 4. So drag force on the car. So drag force on the car increases with the speed. So imagine we have a car here, fancy car, let's say, yeah, maybe, I don't know, new brand car, yeah. So, well, the front should be little smaller than the back side, yeah. Maybe Mercedes, yeah, whatever. So yeah, the drag force is going to increase. What is drag force? Drag force is opposing force, maybe the wind, yeah, or the friction force is also called drag force as well, yeah, from one perspective. Yeah, so let's say this is the drag force, force D, increases with the speed. Indeed. So when you increase, for example, if you're driving a car, or let's say it's better with bicycle, yeah, if you ride it faster, you're gonna feel more wind pushing you back actually. So when you increase the speed, so when you increase the speed, drag force increases. Makes sense, yeah. At 20 meters per second, the total drag force is 400 Newton, pushing back the car. The mass of the car is given to be 1,200 kilogram, and the driving force, so we have a driving, so force from the engine, driving, yeah, it's easy to guess. So yeah, so driving force is going to be 700 Newton here. So which statement about the acceleration of the car at 20 meters per second is correct? So first of all, we have to find acceleration if you pay attention on the options. So the first going with acceleration. So let's see. Acceleration is what? Acceleration, how are we going to find acceleration here? Acceleration. So what we'll find from Newton's second law, yeah? Mass times acceleration. Force. Which force we'll use here? Guess. So it's resultant force, yeah? So this is always resultant force in the formula actually. Yeah. Okay. So what we have here is resultant force. So 700 Newton to the right, to the left 400 based on our picture, equals the mass is also given 1200 kilogram times what? Oops. Okay. Times acceleration. All right. So acceleration equals to 120. Sorry. My bad. Okay. 300. Yeah. 300 divided by 1200. So when you calculate this one, you end up having 0.25 meters per second squared. Okay. So from the options, we eliminate C and D. Let's see what we have on A and B. So acceleration is 0.25 meter per second, but will decrease as time passes, will increase as time passes. So how we will assume, how we can find out the question, how it's gonna act acceleration on this car. So here it's given, yeah, drag force increases as speed increases. So this side actually increases. So 700 minus 400 becomes 300, yeah, divided by 1200. Well, if that value 400 increases to let's say 500 or 600, what makes the acceleration increase or decrease? Of course decrease, yeah. So this is constant. If this drops down, acceleration would drop down as well. Well, from here we can guess as well, or from here too, yeah. It's going to decrease definitely the acceleration. So 4 is going to be A here. All right, next question. A rectangular swimming pool is 50 meters long, 25 meters wide. It contains water at a depth of 2 meters now. The density of the water is given to us. What is the mass of the water? Well, it's not that difficult, yeah. So we have a swimming pool, let's say. So let's say this is going to be 50 meter wide, and let's say, sorry, long, length, yeah, and 20 meters wide here, and 2 meters of height here, let's say 2 meters of height. How are we gonna find the mass of the water here? Well, we'll use density formula, yeah, mass over volume here. So density is going to be 1000. Mass is the question. Volume is going to be what? Well, we should be a little careful here too about the units here. Meter given, meter, meter, meter. No problem. 50 times 25 times 2. If it was not meter in either of them, maybe the dimensions on or the density. So we have to have some conversions here. Yeah. So mass equals to simply 1000 times 50 times 25 times 2. Well, calculator is allowed in this paper, so you can just take your calculator out. Don't act smart, yeah. Well, you might be, no problem, yeah. You can act smart, but just avoid doing some, even solving in your brain may take a little time, yeah. So I would suggest just go with calculator, and you'll end up having 2,500,000 and kilogram. 2.5 m kilogram megakilogram, you can say, yeah. So it's D, whatever. So question number 6 here. So object is rising vertically at constant speed. So read the question carefully. The object is rising vertically up. So it will rise up, of course, yeah. Vertically up at a constant speed through the water. Constant speed, okay. There are 3 vertical forces acting on the object: weight, drag force, and upward force, probably upthrust force, yeah? Yeah. Which diagram shows the magnitude and the direction of the vertical forces acting on the object? First of all, constant speed. Speed is constant, acceleration is 0, yeah? So what does this guy will tell us? Resultant force is 0, yeah? When acceleration is 0, we'll have resultant force to be 0 here. 3 forces we have. All right, first of all, let's find resultant force on each of that one's options, and we'll go. So 1 plus 2, 3 up, 3 down. So resultant force is going to be 0. It might be our option. So 3 plus 2, 5 up, 1 down. Oh, resultant force is going to be 4 newtons up, let's say, yeah? It's not an option. So 2 up and 4 down. So resultant force here is going to be 2 newtons down. Well, it's very contradict to our statement. Anyway, so D, resultant force is going to be 3 up, 1 plus 2, 3. 3 down, 0. So 0, yeah. 3 up, 3 down, 0. Okay. A and D left. Then what? Oh, so we'll go with the definition of the forces now. Weight will always act down. This is correct. This is correct. Drag force, it always act against the motion. Always against the motion, yeah? Against the motion here. Oh, so it's going up, drag force have to be down. This is up, is wrong. All right, so our question is D. D is down, and upthrust always upward, yeah, on the object. That's correct. So D is correct. Question number 7. 2 boys here of equal weight. Okay. Weight of B1, let's say, weight of B2, and they are equal. Weight of B1 equals to weight of B2. You can just call it weight of boys, B, yeah? Sit on one side of the seesaw. Their father sits on the other side, having 1000 Newton here. The seesaw is balanced and being used so that it moves up and down. So it's balanced. It's a very important part here. During one part of the cycle, the father descends, father lowers down to a distance of 40 centimeters. At the same time, when this happens, what happens? At the same time, the boy nearest to the pivot, so B1, boy 1, rises 20 centimeter up. Other boy rises 80 centimeter up on the other side, yeah, a little far. So what is the weight of each boy? Well, here we have to solve with moment, yeah, definitely. Father pushes. Well, we have school and the end year program, so it's a little loud, but it's okay. Probably, no problem. So yeah, the father, weight of father, let's say, will push counterclockwise. Boy 1 will push clockwise. Boy 2 will push clockwise, and it's balanced. So can I say moment counterclockwise is always equal to the moment in the clockwise? Sum of the moments. This is the correct equation. It would be, yeah? All right. On the counterclockwise, we have only one moment from the weight of the father. So weight of the father times distance of the father equals to weight of the boy 1, distance of the boy 1, plus weight of the boy 2, oh, let me erase this side, so yeah, so we'll have father, yes, and distance of the boy 2 here. What parameters we know? We know this 1000, the rest we don't know. That's why this guy will help us to somehow define the distances. Yeah, how? So seesaw used to be like this. This is the pivot. Yeah, this is the pivot. Now, father lowered a little bit down. So let me just draw the seesaw like this. Yeah. So it lowered down here. Yeah. It says descends. Yeah. So let's say father was sitting here. So 40 centimeter, this guy descends down. The first guy, let me increase. First guy is going to be 20 centimeter here. The second boy, 80 centimeter here. Yeah. Let me write a little bit. Okay, 80 centimeter here now. What is this? This is actually triangle, yeah? This is a similar triangle. Let me change the color. We will see blue. Okay, so it's going to be triangle if we see. So similar triangles. Not really, let me change. Okay, it's going to be here one triangle, another triangle, and the third one is going to be the big one, yeah? All right. So this angle and this angle is same. So we can use what similar triangle rules here to find the directions basically. So this is going to be distance of the father till, let's say, pivot P. And this is going to be distance of the boy 1. And this is going to be distance of the boy 2. We should be very careful. It's not from here till here now. It is not, definitely. All right. So the distance lever arm, let's say, it's going to be from the rotational point to the location of the force, basically. And yes, guys, when we go here, we should complete, when we talk about the moments, guys, we should be a little careful with the, when we say moment equals to force times distance, what we really mean, force have to be always perpendicular to the distance, okay? So this is very important to note. Okay. From here, what we can say, all right, from here, from triangles, we can say that science rule, so 40, oh, we don't have enough space, okay. 40 divided by d of father equals to 20 divided by d of p1 equals to 80 divided by d of p2, all right? So, let me change, let's make it more, right? Okay, we'll get the first one. All right, let's see what we have. We can have it. So 40 divided by df equals to 20 divided by d boy 1. All right. So if we just cross product them, so db1 times 40 equals to 20d father. So db1 equals to 20 over 40, it becomes 1 over 2d father. Yeah. Just leave it here. Okay. Let's take the first one and the last one. So father compared to boy 1. Now let's compare father to the boy 2. So 40 divided by d father equals to 80 divided by d boy 2 here. Cross product again. So 40 d boy 2 equals to the 80 times, okay, 80 times df, the father. So just take 40 to other side, d boy 2 is going to be what? 2d father, yeah? Twice of the father's length. All right, we will use this one in a dimension, okay? All right, what did we say? Okay, weight of the father is given, 1000 times, just write d of father, no problem, equals to weight of the boy 1, that's the weight of the b1. Can we just say all of them to be just weight of the boys? Because they're equal, yeah? It's stated here. So, VB times boy 1, but distance is not equal, okay? You should be careful. Okay, we just found to be 1 over 2 d father plus, again, weights are same, B2 in terms of df to 2df, yeah? It's here. and this is here, yeah? Okay. What we'll have, 1000 times df, just leave it here, 1000 df equals to, well, can we just do it like this? So let's erase this one. What we'll have, let's erase the f's, yeah? Yeah, it's bingo, gone. All right, then 1000 equals to VB over 2 plus 2 VB. Just sum them up. So VB 2 times 2 VB, 4 plus 1, 5 VB over 2. So we'll have, well, when you just 1000 times 2 becomes 2000 over 5, take the other side, becomes 40. So VB equals to 40 newtons here. So our answer is 40. So answer is D. Sorry. It's B. Yeah? Not D. It's B. Yeah. Belgium, B. All right. Question 8. Student measures the length of the spring. Then she attaches different weights on the spring. She measures the length of the spring for each weight. The results are shown to us. What is the extension of the spring with the weight 3 newtons attached? So we're looking for the extension only. What is extension? Let's say we have a spring. Let's say it has 5 centimeters. This is the length of the spring. But when I put the load here, this guy will be stretched a little bit. Yeah? Maybe it will become here. So this side becomes extension, okay? So extended part is called extension. All right. So when it's 0, 520, this is our original length, okay? But when it's 3 Newton, the whole length becomes, this is the whole length, it's not extension, be careful. All right, from 520, it being extended to 533 here. So basically what we will do, extension equals to final length, you can say final length divided by original length, yeah? 533 divided minus 520. So our extension is going to be 13 mm, yeah? Also be careful of the unit. Let's look for the 13 mm. Oh, it's here, all right? It's D. Next question. Momentum of body is changed by force acting on it for a period of time. Which action increases the change in momentum? Oh, we're talking about change in momentum. Which one will increase? So what is change in momentum? It's called impulse. What is impulse? Force times the time during that force being acted on it, yeah? Alright, so change in momentum equals to force times time. So force and time being compared. In order to increase change in momentum, we have to do what? Let's see. A, doubling the force, halving the time. Oh, 1 over 2 times 2, same. So it's not doing nothing here. Doubling the force, same time. 2F times 1, of course. It's increasing, nice. Our answer is B. Let's see C. Halving both will decrease. Halving force, doubling time. Again, it's same like A, yeah? It's not the option. So correct answer is B. Next question. Equation used to find a change in gravitational potential energy of an object can be written as so GP wrote us as in terms of Y, Z, delta H. Well, EP is going to be gravitational potential energy. Delta H is going to be change in height. What is the Y and what is the Z values? Oh, so GPE, okay. mg height, can we just say this one? If this is changed, this will be changed too. So this is already there. So Y must be m, Z must be g, gravitational field strength, yeah? Y must be mass, and this is, yeah, so it's A, easy one. Question 11. Machine has a power input of 200 watt and useful output of energy 1 kilojoule in 6 minutes. What is the efficiency of the machine? Well, here, efficiency, when we talk about efficiency, guys, we have to compare initial and final one, simply input and output. So we know the power input to be 200 watt. In order to find the efficiency, we have to have P output, okay? So how we'll find P out? It's not directly given, so we can find it, no problem. Energy over time, this is our question, formula, path. So energy is 1 kilojoule, simply 1000 joules divided by 6 minutes. time should be in seconds, okay? Don't go with 6 minutes, just go with 6 times 60 seconds now, all right? So when you calculate this one out, what you will have, let me find okay, my calculator here. So 1000 divided by 6 times 60, we will have 25 divided by 9, or simply 2.78 if you round up, yeah? 2.78, yeah? All right, is this the answer? No, not yet. This is just the output. So we had 200 watt as 100%. Don't forget, input is going to be always 100%, okay? You have to assume, yeah. Then the output, we don't know. We don't know percentage, but we do know what, yeah? It's watt here. 2.78 watt equals to what percent? That's what we don't know. This is direct proportion cross product here. So 200 times x equals to 2.78 times 100. Bingo. So when you calculate this one, the 2.78 times 100 divided by 200 is 1 point something, yeah? Sorry. 2.78 times 100 divided by 200. So we'll have 1.30, very close to 1.39, okay? So it's going to be 1.4. 1.4 units percent, yeah? The unit is always percent, yeah, here. So it's C. 11 is C, guys. 12, what is the unit of power? What is the unit? What is the unit of power? Definitely. Okay. The diagram shows a rectangular block of weight 16 Newton and resting on the flat surface. So it's resting with this scenario, in this position, in this, let's say, picture, shown on this picture. What is the pressure at the base of the block? So simply, what is the, okay, this is the area, yeah? So pressure, so force over area. So force is given as a 16 newtons, weight, that's the weight, yeah, force. And the area is, which area we are taking? So definitely we are taking what? 4 centimeter divided by, sorry, 4 centimeter multiplied by, the weight is going to be 5 centimeter, okay? So here, guys, you should be very careful. Here you should be very careful. So Newton per centimeter cube. The unit is centimeter cube. No problem. It's okay. In this case, sometimes they will give in terms of Pascal, so we should be very careful. If it's Pascal, it will be Newton per meter square, okay? Pascal equals to Newton per meter square, 1. So in that case, we had to convert, but in this case, specific case, no need. So simply 4 times 5 centimeters square, yeah? Anyway, so it will be 16 divided by 20, so it's going to be 1 point something, it's 1.8, yeah? 1.8 Newton per centimeter square, so answer is C. Okay, so let's move with another question, question 14. An oil tank has base of an area 2.5 meters square and filled with the oil to the depth of 1.2 meters. The density of oil is given 800 kilogram per meter cube. What is the force exerted on the base of the tank? Okay, so we have a scenario of such. Well, it's not said any what kind of tank. Okay, it's making a little sound here. All right, so let's say it's cylindrical tank, no problem. Any, yeah, any. So this is going to be base, okay? So we have an oil, let's say. We have an oil somewhere here, let's say. Maybe different color, this color, yeah? It is filled with the oil here, yeah? Density of the oil is given to be 800 kilogram per meter cube. All right. What is that? Due to this oil, how much force is being exerted? Sorry. It is this one, yeah? Okay. Here in the base one, okay? How much force due to the oil here? Well, how will approach to solve this problem? Well, force. When we talk about force in terms of pressure, because oil is applying pressure, and this pressure means force per area, yeah? So first, force per area, yeah. But how are we gonna find pressure from here? Well, if you remember, we have another pressure formula for liquids, basically fluids, yeah? So pressure for the liquid is going to be rho, the density of the oil or density of the liquid, G, whichever the gravitational field strength of that planet, so it's Earth definitely, 9.8, yeah? And height, it depends on the height too, exactly. So in this case, rho is given as 800 kilogram per meter cube, G 9.8, yeah? And the height is 1.2 meters here. So when we calculate this value, so 800, not 1000 is the water, 9.8 times 1.2. So we will have very close to 9400, or simply say 9408. It's the exact number. Yeah, this is the exact number. So what? Pascal, Newton per meter squared. So that's going to be our pressure. So 9408 Pascal, simply Newton per meter squared, equals to area. What is that? Area is given as 2.5 meters squared. Again, I'm doing the same mistake. Okay, the force, that's the question, yeah? Area 2.5 meters squared. Okay, so simply force is going to be 9408 times 2.5, which is going to meter square cancelled, yeah? Now see, meter squared, we should be careful, Pascal is meter squared always. Now, this value times 2.5, you will get a very close to 23,500. So 23,500 newtons basically, yeah? So which one correct answer, which one is the closest? So B is the closest here, okay? Maybe if you use G to be 10, it will be more close. But anyway, so it's going to be very close to 2000 and... Sorry, it's not this well. This one is wrong, yeah. This is the correct one. 24,000, guys, okay? We should be very careful. 24,000, correct answer is going to be 14, so don't do this mistake, all right? Yeah. All right, it's from one side, we may say this is the lesson, yeah, not to rush with the question, the answers. All right, question 15. A sample of gas is trapped in a rigid container. As the temperature of the gas increased, the pressure increases. Which statement is correct? So we have a rigid container, let's say, yeah. Rigid means it's not changing its volume, okay? So that's why this is rigid. All right. So temperature increase. How does temperatures, the pressure increases? Temperature increase, the pressure will definitely increase, yeah? So which statement is correct? Gas molecules have not correct. Be careful. The gas molecules have greater kinetic energy. This is correct one. It's not an option. Gas molecules hit the wall of the container harder. Well, of course it will keep harder because it's going faster. When temperature increases, guys, for example, imagine in the room, yeah, when you increase the temperature of the room, molecules keep moving faster. So imagine you have two cars, yeah, with the same mass. One is going to hit the wall going with a less speed, another is going to hit the wall going with higher speed. Or you may imagine yourself, yeah. If you go hit the wall by walking and you go hit the wall by running, which one is going to have higher impact or higher hitting harder? Of course, higher speed, yeah? This is correct too, it's not an option. The gas molecules hit the wall of the container more frequently, definitely. So it used to travel slower, it's gonna maybe hit once or twice, let's say, what is that, imaginary. Once, if it goes faster, it's gonna hit more, yeah? So this is correct, which is not an option. So the gas molecule move further, well, it's not moving further apart. This is definitely wrong answer. What happens when the temperature of liquid increases? So mass of the liquid increases. Guys, mass will never change, okay? Temperature of the liquid. So we're talking about the liquid. We're not talking about the liquid changing to gas. Liquid temperature increases, liquid remains with the same liquid here. So mass is not going to change here, okay? It's about the volume. volume will increase definitely, because what? They gonna move a little bit or vibrate a little bit more now. So it's gonna vibrate more. It makes the volume of the, let's say certain that one, liquid gonna increase. If same amount of particles here, guys, okay? How about density? Density increase and density decreases. Density will decrease, it becomes less dense. More dense, more packed. So they are going to vibrate less. Less dense, less packed means they are a little apart from each other, which is the case in this case, yeah? The volume of the liquid is going to increase, making the liquid less dense. So C is the correct answer. A bar of metal, which is good thermal conductor, is heated at one end. What is the main method of transferring of thermal energy along the bar? So this is a little, okay, you may say it's heated. This is definitely conduction method here, yeah? It's about the conductors. You may think in terms of electricity, guys. It's far less, like, let's say there are little differences, but you may think in terms of electricity as well. So how this energy being transferred? Lattice vibration, now, movement of atoms. Atoms are not moving here. Basically, electrons are transferring. So correct answer is C, guys, here, okay? Vibration of atoms of the, well, they do vibrate, but they don't carry energy, yeah? So question says, what method transfers thermal energy? So it's going to be C.